Now class time, the more getting this little bit of campus.
Okay, students, good morning to all. And today also we are going to continue the same chapter, chemical bonding. So into that, we are going to discuss about today's topic, orbital overlap. Orbital overlap. Okay. So yesterday we discussed about how that atomic orbital of hydrogen combines to form a molecular orbital of a hydrogen molecule, H2 molecule. Like that, today also we are going to discuss how that atoms combine to form a molecule. Suppose if you are combining atoms, combines to form covalent bonds. Okay, to form a covalent bonds, and this refers the formation of a molecule. To form a molecule, and we know that how these molecules are formed. So the molecules can be formed by the overlapping of the atomic orbitals. That is the molecule. How this molecule is existing, this molecule can be formed by the overlapping of an atomic orbital. That is atomic orbitals. Okay. Now, if you take an example for a hydrogen molecule, we know that the hydrogen, one atom, so atomic number 1, the atomic orbital 1s1. So 1s1 orbital contains how many electron? Means only 1 electron. Okay, same way, second hydrogen atom, if you take second hydrogen atom, so that is also containing only 1 electron. So in the 1s orbital contains only 1 electron. Okay, this is this 1s. Okay, this 1s1 and this 1s1. This is only named as a atomic orbitals. So whenever the atoms combines, the atomic orbitals should overlap. The atomic orbital should overlap. Whenever this atomic orbital overlaps, we will get a formation of a covalent bond. Okay, so this is only given. So the atomic orbital of the combining atom should be overlap. Okay, and it forms a molecule. It forms a covalent bond. Okay, and whenever this atomic orbital overlap, like for example, if you take the structure of this two hydrogen atom, we know that. So one hydrogen atom. So I can represent this one hydrogen atom like this. So one hydrogen atom, nucleus. Okay. So this contains only one electron. Okay, only one electron. The same way, another hydrogen atom, if you take that, another hydrogen atom, nucleus, how many electron? Only one electron. Okay. And when this combines to form a molecule. Okay. So what happened? Whenever this formation of a molecule, the two atomic orbitals should overlap. Okay. This is the first one. And this is a second hydrogen atom. Okay, and the two electron that should be present here. Okay, one electron here and another electron here. So like this. So whenever if you take this containing one atom, it refers the atomic orbital. Whenever we are talking about in terms of a molecule, this is nothing but molecular orbital. Whenever if you take in that molecular orbital, the electrons are present where it is present. That is, this is only called a bond pair. Okay, these two electrons only named as a bond pair. Okay, so whenever this bond pairs of electron will occupy only in the overlapped region of a orbital. So this bond pair, where it is present, okay, that should be present in the overlapped region. Okay, so this is overlapped region. Okay. And completes the atomic orbital overlapping only will give a molecular orbital. Okay, and this is how the formation of a bond and the formation of a molecule. If you take two atoms, the atoms should combine to form a molecule. So how this atom is combining means by using of atomic orbitals. Okay. So what is atomic orbital? Where the electron is present. Suppose if you take a hydrogen, it is consisting of only one atomic orbital, contains only one electron. So just we have taken one electron system and shown that how that bond pair and where the bond pair is present. Okay, so the bond pair should be present only in the overlap region. So the bond pair should not be taken by any one of them. It is not possible. So it should be present only in the overlapped region. Okay, and next we are going to see about depending upon the nature. Okay, suppose if I am taking depending upon the nature of the overlaps, because here mainly the formation of a molecule means you should overlap the atomic orbital. So based on the overlap, okay, so based on the overlaps, if you take the overlaps, so based on the overlaps, we can classify the covalent bond as covalent bond. Okay, so we can classify the covalent bond. Okay, so the classification of a covalent bond. So whenever this covalent bond, we can classify into two types. One is a sigma bond. It's a sigma bond. The symbol we can use sigma. Okay, so this is a sigma bond. And second one, it is a pi bond. Second one is a pi bond, and symbol we can use as pi. Okay, so based on the overlap, we can classify the covalent bond as two types. Okay, what is the first one? Sigma bond, and second one is a pi bond. Okay, now sigma bond designated as symbol sigma, and pi bond as designated as by using of a pi symbol. Okay, and next, what is this sigma and the pi bond? We want to know what is sigma and the pi bond. Okay, so first let us take the sigma bond. we want to find out what is sigma under pi bond. Okay, so for that, first take a sigma bond. Okay, now how this sigma bond is formed? When two atomic orbitals overlaps linearly. So, if two atomic orbitals overlaps linearly, okay, overlaps linearly along the axis. If I am taking two atomic orbitals, okay, the two atomic orbitals should be overlaps linearly along the axis. The resultant bond is called the sigma bond. Okay, and this is also called as actually also called as head-on overlapping. Head-on overlap or axial overlap. Head-on overlap or axial overlap. Okay, so now if you take, I'll show the head-on overlap. If you take the p orbital, we know that the p orbital, what is the shape of p orbital? Double shape. If you take any one of the p orbital like this, so this p orbital, suppose if I am taking this p orbital shape, one p orbital, you take any one of the p orbital, okay, so one p orbital, and second p orbital, let me show like this. This is second orbital, p orbital. Okay, so when this two p orbitals, this atomic orbital overlaps by using of this hex, overlap by using of this hex, like this only forms a head-on overlapping. Okay, so the hex of atomic orbital overlaps means we can call it as the head-on overlapping or through the axis. So if you take this will be your molecular axis. Through the axis also it will be overlapping. So like this is called an axial overlap. So what is sigma bond? Two atomic orbital overlaps linearly along the axis. Okay. So the overlapping should be taken only in the axis. And this sigma bond also named as head-on overlapping or axial overlapping. So just I have shown by taking an example of what? P orbitals. Okay. So any one p orbital you can do. So px, py, pz like that. Okay. And there is also a possibility of formation of one more possibility, overlapping of a s orbital. Or you can have a chance of s and then p orbital. So this overlaps also. That is, for example, overlaps of, you take the overlaps, okay, that involves s orbital, overlaps of s orbital. So the possibility, the s atomic orbital and the s atomic orbital of another atom can overlap. Or if you take the s orbital of one atomic orbital and the p orbital of the another atomic orbital can overlap. So this kind of overlapping also will form a sigma bond. Okay, and show s orbital and then p orbital overlaps. Okay, so this is also formation of a sigma bond. If you take s and the s, so we know already s and the s orbital overlap means if you take atomic orbital of a hydrogen. Okay, so the hydrogen atomic orbitals, we know that this is a nucleus and this is a one hydrogen atom. Okay, and we already have seen this, the presentation of a electron like this. Okay, and same way another hydrogen atom you take, okay, and the electron is present like this. So this is SS. Okay, so this is a atomic orbital of a one hydrogen atom, and this is the atomic orbital of the second hydrogen atom, and this must be linearly overlaps. Okay, because it is spherical in shape. You know that s orbital are spherical in shape, and these two atomic orbitals combine. Okay, so if you are combining like this is like this. So one atomic orbital of one hydrogen atom, another atomic orbital of another hydrogen atom, and the electron is present only in this region. This is called a overlapping region. So this is only called a S overlap. So s orbital of one atom overlap with the s orbital of the another atom. So I have taken only hydrogen as an example. Hydrogen has an atomic orbital 1s1, this hydrogen, and this hydrogen also 1s1. So this two atomic orbital should overlap and it forms a molecular orbital. So this is only called a SS overlap. Okay, and the same way you take SP overlap. So if you take SP overlap, take an example of fluorine. Okay, so SP overlap. Okay, so for that take an example of fluorine and the hydrogen. Okay, and we know that hydrogen has 1s1, the valence electronic configuration, and if you take fluorine, the valence electronic configuration, fluorine is 9, but the valence electronic configuration you have to take only 1s2, 2s2, okay, like it is 2p5, so 2px, 2p y, 2pz1, okay. Now this is only valence electron, 2s2, 2p5, okay. Now you take this s orbital is completely filled, this px also completely filled, py also fully filled, and this pz has one unpaired electron. Now what happened? The 1s1 atomic orbital of hydrogen overlap with the 2pz orbital of the fluorine. Okay, so we know that p orbital, what is the shape? Double shape. So if you take s orbital is spherical in shape. So I can show that orbital hydrogen like this. This is a s orbital containing only one electron. Okay, and same way if you take the fluorine double shape electron, so fluorine has p orbital like this. Okay, containing what? Only one electron in it. Okay. Now whenever these two atomic orbital, like 1s1 of hydrogen and the 2p is that contains one electron, and these two atomic orbital whenever combines, it has a possibility of getting what? Yes, p orbital overlap. Okay, and this sp orbital overlap is shown like this. Okay, so whenever this is a spherical in shape, okay, and this is a overlap like this, and the orbital, the electrons, one electron present here, okay, and the p orbital electron present here. Okay, so whenever these two electrons should be in a overlapping region, so this is called a overlap region. So this is possible overlap region. Okay, and that's a possibility of getting a covalent bond, and this type of bonding only we are named as sp overlapping. So the sp overlapping, it is nothing but the s orbital of one atom should overlap with the p orbital of another atom. Okay, so this type of overlapping will always lead to the formation of a covalent bond. Okay, and similar way, if you take overlap between two p orbitals, overlap between two p orbital, overlap between two p orbital will also results in the formation of a sigma bond. Results in formation of a sigma bond. If you take that two p orbital overlapping, that is also results in the formation of a sigma bond. So if you are taken that x-axis is a molecular axis. X-axis, if I am considering as a molecular axis. Okay, if I consider x-axis as a molecular axis, then px, the p orbital, okay, first p orbital of one atomic orbital will overlap with the second p orbital, that is second atomic orbital of the p orbital. So this also results in sigma bond. So if I am taking x-axis, okay, x-axis, this is also leads to the formation of a sigma bond. Okay, so this is a sigma bond. And the same way, when the two atomic orbitals overlap sidewise. So if I am taking sidewise overlapping, suppose for example, just I have shown this, the p orbital. When we take one p orbital, this is the second p orbital. Okay, so this is the p orbital. And same way, if you take this is another p orbital. So this is the first one p orbital. This is another p orbital. Okay. So this is called a head-on overlap. So whenever this atomic orbital overlaps like this is only named as head-on overlap. Head-on overlap. Okay. And same way. And same way, if you take the two p orbital, okay, so the two p orbital, if it overlaps sidewise, okay, when the two p orbital overlaps sidewise, this gives lateral overlapping. This is called a lateral overlapping. Always we know that lateral overlapping will result in pi bond, and head-on overlapping will result in sigma bond. It results in sigma bond. Okay, and same way, just we know that the covalent bond can be of two kinds. One is the possibility of a sigma bond. The another type is possibility of a pi bond. Okay, so if you take that sigma bond and the pi bond, there is a possibility of SS overlapping, SP overlapping, or PP overlapping will also forms a sigma bond, but the condition is the axis, okay, molecular axis should be consideration. And same way, the two p orbitals, if it overlaps laterally, it forms a pi bond. Okay, now next I'm going to show how the formation of a bond by taking various examples. Okay, so first of all, if you take a formation of a hydrogen molecule. Okay, so if you take formation of a hydrogen molecule. Okay, so how it is formed, the hydrogen molecule? So we know that hydrogen molecule means we have to take two hydrogen atoms. Okay, so each hydrogen atom containing how many electrons? Only one electron. Now I will write the various atomic orbital hydrogen consisting of a 1s1. Same way, if you take This hydrogen also consisting of a 1s1. Okay, now I will show the hydrogen in various atomic orbital. So if you take first hydrogen, so this hydrogen atom consisting of a 1 electron. Okay, so 1 electron. So now I will show that 1 electron like this. Okay, 1 electron present. Okay, and same way the second hydrogen atom consisting of a 1 electron. So this is 1s1 of a first hydrogen. This is the 1s1 of a second hydrogen. Okay, and now these two atomic orbitals should overlap. Okay, so whenever these two atomic orbital overlaps, then there is a chance of getting a molecule. Okay, but how that molecule has formed? In between the two atoms, there is a formation of a one bond. Okay, so the bond can be a covalent bond. The bond can be two types of a covalent bond. One can be a sigma bond or it can be a pi bond also. But there is here SS overlapping. So what is a bond formation? Definitely it is a sigma bond formation. Okay, and that results in the formation of a molecule. Okay, so this is a one atomic orbital of one hydrogen atom. This is the second atomic orbital of a second hydrogen atom. Now the electron, first one electron of one atomic orbital and second electron is present in the overlapping region. Okay, so 1s1 of two hydrogen atom, this containing one unpaired electron. One unpaired electron means single electron overlaps along the internuclear axis. Okay, that should be overlap. Okay, so here the overlapping along internuclear axis. Okay, so here overlapping along internuclear axis. Okay, so what is this axis? Whenever these two nucleus we are going to combine, because the s orbital is spherical in shape. Okay, so here the distance between the two nucleus, okay, that is only called the axis. What the axis that has to connect the two nucleus. So that's why I have indicated internuclear axis. Okay, so this results in the formation of overlapping along the internuclear axis. Okay, and what is the type of overlapping here we found? The yes overlapping. What is the type of overlapping? Yes overlapping. Okay, and next we can take one more example of p orbital overlapping. Okay, so if you take fluorine molecules, okay? So formation of a fluorine molecule. Take F2 molecule. Okay, and we can write one fluorine just valence electronic configuration. You know, fluorine contains how many electrons? 9 electrons. But I am writing only valence electronic configuration. Okay, so valence electronic configuration. So we know that only I am talking the core electron. Okay, just I can show like this: the fluorine electrons 2s2, because 1s2 I have to left. This is the inner electron. 2s2, 2p5. So 2p5 means 2px consists of 2 electron, 2py has 2 electron, and 2pz has only 1 electron. Okay, we know that the p orbital has how many orientation? 3 orientation. So the 2p orbital contains how many electrons? 5 electron. Let us put first 1 electron, second electron, third electron, and fourth electron and fifth electron. That's why 2px2, 2py2, and 2pz1. Okay, so likewise the second fluorine. Okay, this is the second fluorine also 9 electron, but we are writing only the 4 electronic configuration, that is called valence electronic configuration. That is also same valence electronic configuration. So consisting of 2s2, 2px2, 2py2, 2p isn't 1 like this, okay? And if you take this configuration here, the S and the S completely filled. There is no unpaired electron. Px of one atomic orbital and the 2px of a second atomic orbital completely filled. There is no unpaired electron. 2py of the first fluorine atomic orbital and 2py of the first atomic orbital is also completely filled. There is no unpaired electron. But if you take the 2pz consisting of only one unpaired electron, the same way the 2pz of a second atomic orbital contains one unpaired electron. Okay, now you see the two atoms. Okay, the atomic orbital of 2pz only contains unpaired electron. Now this 2pz atomic orbital of a one fluorine atom can overlap with the 2pz of a second atomic orbital of a fluorine, and it leads to the formation of sigma bond. Okay, now I will show the formation of sigma bond by taking the p orbitals here. We know that p orbital, all the p orbital will have a double shape, but especially I am talking in terms of what the 2pz. Okay, p orbital double shape. What this is 2pz. Okay, containing how many electrons? Only one electron. So this one electron, I am showing this one electron, one unpaired electron of one fluorine atom. So I am taking only the pz orbital. You just left x and y. Okay, that will be acting as a lone pair of electron. Okay, and same way the second 2pz orbital of a fluorine. Okay, here the second 2pz orbital of the fluorine. Just I am showing like this. This also 2p, that is p orbital double shape. This also containing how many electron? Only one electron like this. Okay. Now this two atomic orbital overlaps linearly and it forms a overlaps linearly. It forms a covalent bond. But how this linear overlaps? So like this will be present like this, and this will be like this. Okay, containing one electron, and one p orbital lobes will overlap with the another p orbital lobes, and the electron. Okay, those two electrons that has to be present only in the overlapping region. Okay, only in the what region? Overlapping region. So that the 2pz of one atomic orbital of fluorine can overlap with the 2pz orbital of another orbital of a fluorine atom, and this complete overlapping will give rise to this is called PP overlapping. This time I told you PP overlapping, whether in the molecular axis, that always results in the formation of a covalent bond. So here these molecules can overlap linearly along the molecular axis. So that's why PP overlap. Okay. So now the fluorine molecule, what is the type of bond present in between the two fluorine atom means the type of bond is a sigma bond. Okay. And which orbital involved in the formation of a molecule means the 2pz atomic orbital only can take part in the bond formation. You should be able to say the answer, which orbital, what is the valence electronic configuration, and what overlapping possible. Okay, now I have given SS until PP. Okay, so let us take one more example, S and P orbital overlap. If you take SP orbital overlap, example, you take a example as HF molecule. HF. Okay. And in HF molecule, we know that already the hydrogen has only one electron. So it has atomic orbital, 1 is 1. And same way, the fluorine has how many electron? 9 electron. But the valence electron, already we have seen that the valence electronic configuration of a fluorine atom, 2s2, 2px, okay, 2px, 2p, y2, and 2pz1. Okay. Now, your guess what could be the atomic orbital and which atomic orbital can overlap. Okay. So now here there is a chance of this 1s1 containing one unpaired electron, and same way this 2pz containing one unpaired electron. So these two atomic orbital only can overlap, and there is a formation of a bond. Okay. And now there is a formation of overlapping S and P orbital, where the P orbital should be considered as a molecular axis. Okay. So the if you are taken that this will be a molecular axis, and there will be a formation of a what bond? Only a sigma bond. So I will show the S orbital. We know that S orbital of hydrogen. Okay. So if you take the S orbital of hydrogen like this, containing one electron, this is a hydrogen. So what is this atomic orbital? 1s1. Okay, of hydrogen can overlap with the P atomic orbital of the fluorine. We know that the P orbital has what shape? It is a double shape. So you can draw the double shape. Okay, and this contains electron. So this electron has only one electron. So each atomic orbital should contain how many unpaired electrons? Only one unpaired electron. So likewise here also it is a spherical shape hydrogen. It is a spherical shape, and the p orbital also it is a double shape. So this S and the p orbital can overlap and leads to the formation of a sp overlapping, and this possible, that is the S orbital. The S orbital can overlap with the p orbital. So this is called the overlapping. Likewise, okay, and the two electrons, one hydrogen electron and another fluorine electron designated like this. Okay, and this is called overlapping region, and this type of overlapping is nothing but sp overlapping. So this sp overlapping leads to the formation of a sigma bond. Sigma bond. We should able to see that what is the type of overlapping and what could be the possibility, that is whether SS or SP. Okay, because sometimes the PP orbital can overlap leads to the pi bond, but the P2P orbital should be overlap laterally. Okay, the 2P orbital overlaps linearly, that is called a head-on overlap, that is only a covalent bond. So you should be able to differentiate which is covalent bond and which is a pi bond. Okay, now I will tell you one more example of showing the pi bond formation by taking an example, oxygen. Okay, O2 molecule. So here I will show the overlap of formation of sigma bond as well as formation of a pi bond. Okay, so we know that oxygen. So oxygen molecule contains how many oxygen atoms? 2 oxygen atoms. So first of all, we should be able to find out what is the atomic number of oxygen. The atomic number of one oxygen. If I take the one oxygen atomic number 8. Okay. So let it write the valence electronic configuration for oxygen. We know that inertial we have to leave. So, but I am indicating inertial also. 1s2. 2s2, 2px2, 2py1, 2pz1. We know that 1s2, 2s2, 2p4. So totally 8. But we are taking only 2s2, 2px, 2py, 2pz should be considered as a valence shell. Okay, so this consists of s orbital 2 electron, 2px 2 electron, 2py 1 electron, 2pz 1 electron. So 2 unpaired electrons are present in the py and the pz. Okay, let me take another oxygen atom. The same the configuration because 1s2, 2s2, 2px2, 2py1, 2pz1. Okay. So we know that each oxygen atom has a valence electronic configuration 2s2, 2p5. Okay. So now 2s2, 2p5 of one atomic orbital can overlap with another atomic orbital. Okay. So now we have to look at this. Okay. Now I'll draw the structure of this electrons. Okay. So if I take oxygen 1, so this is the first oxygen. Okay. So if I take oxygen, first oxygen. So I'll draw the structure. You leave out this S1s, which is not included in the valence chain. This is a inner shell electron. You leave this and you take a valence electronic configuration. Now, just taking an example of valence electronic configuration. So we know that 2s2, because s orbital one means spherical in shape. The 2s orbital containing how many electrons? 2 electrons. And the same way, the 2p orbital. So what is the shape of p orbital? We know double shape. The p orbital has how many orientation? There are 3 orientations. So the p orbital are designated as 2px2, 2py1, 2pz1. Okay. Now just put the electrons in the orbital. So here 2 electron, here only 1 electron, here only 1 electron. Likewise. Okay, I am showing only the valence electron. Same way if you take oxygen, second oxygen. Okay, so here also there is a possibility, the same type of orbital present. So 2s2, 2 electron. And same way we take the p orbital. So here also there are 3 possible orientation. 2px 2 electron and 2py 1 electron and 2pz 1 electron. Now you show that this 2s completely filled, and same way this 2px completely filled. But whereas you take this p orbital, py, only 1 unpaired electron, and pz consisting of only 1 unpaired electron. Okay, now here the bond can be formed in between the 2 oxygen atoms. Okay, so by taking a atomic orbital, only 2p1 and 2pz. Now, if you take the 2py and 2pz, the pz orbital, okay, that is 2pz orbital, it is taken as a molecular axis. And this forms a sigma bond. So this 2pz forms this overlapping of, that is the 2pz1 electron of first atomic orbital of oxygen should overlap with the 2pz orbital of the second oxygen atom, and this overlapping will give rise to only sigma bond. Okay, and same way, if you take the 2py, the 2py containing 1 unpaired electron. So those 2 electrons should overlap and it forms a pi bond. Okay, this is not in a molecular axis, so that's why lateral overlapping, there is a formation of a pi bond. Okay, so now I'm going to show the diagram for the formation of an oxygen molecule. Okay, so which atomic orbital you have to take? the 2pz and 2py. So each pz orbital has lobes, has how many lobes? 2 lobes. So the pz, okay, so the pz I am showing like this, that is 1 fluorine pz like this. Okay, this is 1 fluorine, just you are taking 1 fluorine. Okay, so first is okay, this is 1 oxygen atom. Just I am taking 1 oxygen atom. The 2pz orbital. This is pz. Pz. Okay. Now the pz containing how many electron? Only 1 electron. Okay, and same thing. Second 2pz orbital of the second oxygen atom. Okay, so now this p orbital pz. This is a pz of a second oxygen atom. Okay, this is O2 you take, this is O1 you take. Okay, second oxygen atom. So the 2pz of the first oxygen atom overlap with the 2pz of the second atomic orbital, and the electron will be present only in the overlapping region. This is called a PP overlapping, that is also in the molecular axis. PP overlapping, that is in the molecular axis. So this forms a sigma bond. What bond? A sigma bond. Okay. And next you take a 2py orbital. Okay. Each 2py atomic orbital contains how many electrons? 1 unpaired electron. Okay. So those 1 unpaired electron should overlap with the one more atomic orbital of the same type with the second oxygen atom, and this gives rise to what bond? Pi bond. Just I have given here pi bond. Okay, now I am showing the p orbital overlapping. So we know that one p orbital has how many lobes? 2 lobes. So p is 2 lobes, one more p is 2 lobes, and by overlapping, one of the lobes can overlap with the other lobes. That's why it leads to the formation of a sigma bond. And same way, if you take the 2py orbital, okay, so now I will show the 2py orbital. Okay, so for first oxygen atom, the 2py, the axis. So just I am taking this is a z axis. Okay, now I am taking this is a y axis likewise considering. So I am drawing like this. That is a one lobe of p orbital, another lobe of a p orbital. Okay, so this is a 2py. 2py. Okay, but each will contain how many electrons? Only 1 electron. Okay, another oxygen atom that is containing a one more 2py atomic orbital. That 2py atomic orbital, just I am showing like this. The 2 lobes. This is a 2py. Okay, 2py containing how many electron? Only 1 electron. Okay, now the pz is considering as the molecular axis. So remaining whatever may be x and y, it is not considering as a molecular axis. This 2py of first oxygen atom atomic orbital overlap with the second oxygen atom 2py atomic orbital. This overlaps like this. This is called a lateral or sidewise overlapping. Okay, this is called a lateral or a sidewise overlapping, likewise. Okay, so this leads to the pi bond. This is this overlap is not in the molecular axis. That is only in the sidewise. So those 2p orbital can overlap only in the sidewise, and it leads to the formation of a pi bond. And one more thing, just when you look at the remaining, the 2px containing 2 electron, okay, and this. And 2s containing 2 electron. Each 4 electron will be considered as a lone pair of electron that is present on the oxygen. If I am showing the oxygen like this, we are showing, no, this is only called the lone pair. So only the electron present in the py and pz orbital should be involved in the bonding, and remaining the electron present in the s orbital and the px orbital electrons, that is considered as a bond pair. Okay, and just I am showing here there is a overlapping pp overlapping, but one pp overlap will show the sigma bond, another pp overlap will show a pi bond. Okay, so this is an example for pp overlapping sigma bond and pp overlapping pi bond. Okay, and today in this class we have discussed about only the orbital overlap. Okay, the orbital overlap. So we are going to discuss one is how this overlap atoms should combine, and it forms a covalent bond. This results in the formation of a molecule. And what could be the overlapping? Overlapping between the two atomic orbitals, and the electrons will be present only in the overlapping region. And based on the overlaps, just we classify the covalent bond into two types. One is sigma bond, sigma, simple, and another one is a pi bond. And what is sigma bond? Two atomic orbitals overlap linearly along the axis, and it is also called as head-on overlapping or axial overlapping. And this will give rise to overlaps of a s orbital. Just I have shown that overlap of a s and the s and the p or pp. Just you have to consider as a molecular axis that shows the sigma bond, and in the same way, okay, so lateral overlapping, whether the p orbital it is not in the molecular axis, the remaining will be considered as a pi bond, showing the formation of a pi bond. This I have taken an example, formation of a H2 molecule, I have shown SS overlap, formation of fluorine molecule, I have shown PP overlap, and the formation of HF molecule, just we have shown sp overlap, and in oxygen molecule alone, the pp overlap, one is giving sigma bond, that is pz, and pyb is a pi bond. Students, can you hear me?
Yes, ma'am.
Can you hear me now?
Yes, ma'am. Ma'am.
Yeah.
Yes, ma'am. No, ma'am. No, ma'am.
Yeah. No doubt.
Ma'am.
Okay, so you know how the formation of sigma bond and pi bond?
Yes, ma'am. Yes, ma'am.
Okay.
Yes.
So now what is sigma bond? How that atomic orbital overlaps? Can you hear answer?
Linearly along
Two
the axis.
atomic orbitals overlaps linearly along the axis.
Linearly along the axis.
Overlapping. Eva, sigma bond. Okay. Bond. How the pi bond is formed?
Laterally
Overlapping, or you can say sidewise overlap.
Sidewise overlap.
So how the molecule is formed? Can you see in single line?
Overlapping of atomic orbitals.
Overlapping of an
Atomic orbitals.
Did you catch that? What is? Can you differentiate what is atomic orbital and what is molecular orbital? Before the formation of bond, that individually atomic orbital. And students, now you take your break. Get ready for the next class.